So, ladies and gents, this is the last new thing we are learning for this unit, and it's kind of going through, so you guys understand that when you added more light bulbs when you were in series, it did what to the resistance? It increased, right? And you were able to visually see that because your lights actually dimmed, right? Well, there's a way that we can actually look and see how much current is flowing through a circuit, how much resistance there is, how much voltage there is. And that's actually by utilizing what they call an amp meter, right? And so they can actually test to see, well, how much resistance is actually in that circuit. But all of our circuits that we did are pretty simple. Now, once you move on and you go into like engineering or stuff like that, physics, they kind of up the ante a little bit. So I just want to spend about one day kind of introducing this to you so that you guys at least have seen it at one point in your life before you get to that class. So yesterday and the day before, we were building circuits, and you should be able to look at all of our circuits and tell me whether or not it is in series or in parallel. So these two are in series. These two are in. These three are in series. These three are in parallel. We have series, parallel. And then look, oh, this is where it starts to get harder. These two are in parallel. These two are in series. So what we want to do, and the overall goal, is to figure out how much total resistance is there within our circuit. That's the end-all goal. So we are going to be using two different equations today to solve for the equivalent resistance. And how we actually solve for it is different based upon whether the resistors are in parallel or in series. A light bulb is a resistor. We just diagram it as something else because we're saying, well, hey, we're using the electricity to actually produce light rather than just restrict the flow of electrons, right? Our chargers restrict the flow of electrons. That's a resistor, right? But it's not producing a light. So that's why we use different symbols for those ones. So slide 3 is the one that I want you guys to be on and to be working on it with me, okay? So our goal is to be able to learn how to draw resolved circuits, okay? So the first one I want you guys to take a look at is we have resistor 1, 2, 3, and 4. Which ones can you tell for sure are in parallel? 2 and 3. And so as we go through and we resolve our circuits, you want to take it one step at a time. So what I'm going to do is I'm going to circle those, and I'm going to say they are in parallel. And then I need to draw my next picture. I still have my battery, so you guys draw your next picture. Still have your battery. That's connected to resistor 1, which is connected to now the resolved resistance of 2 and 3. And then we have one final resistor down at the bottom, resistor 4. So now that I just simplified resistor 2 and 3, can you tell pretty easily these three are now in what? Series, right? Those now are in series. So my final diagram is going to have my battery and just one resistor. And that's it. Now, we can actually solve for the equivalent resistance. We can actually solve for that equivalent resistance. So this one right here, our 2 and 3 were in parallel. So look at the board. My equation says my parallel, in order to solve for that, I have 1 over the equivalent resistance equals 1 over resistor 2, which is 8 ohms, plus 1 over resistor 3, which is 8 ohms. All right, now I know this is going to be super tough math right now. How many eighths? 2 eighths. Yeah, REQ, resistance equivalent. Now, do I want 1 over REQ or do I want REQ? I want REQ. I want to know what the equivalent resistance is. So, what do I have to do to get REQ? Now, if I wanted, could I go crisscross? So I have 8 equals 2 REQ. Then divided by 2, and I figure out that it equals 4 ohms. Could I do that? Or could I just go flip and do the inverse? Could I flip it and go, then that's REQ over 1, which is just REQ, 8 over 2, which gives me 4 ohms. Could I do either? Yeah. I think it's definitely easier just to flip. The thing is you got to remember to flip. Otherwise, your resistance is 0.25 versus 4. Okay? So it's up to you how you want to flip that. So then let's look at our next picture. Our next picture, this is 5 ohms. We now have 4 ohms here and 6 ohms at the bottom. Since those are all in series is going to add straight up. So I just add resistor 1 plus 2 plus 3. So 5 plus 4 plus 6 is 15. So my total resistance in the circuit is 15 ohms. 15 ohms. The picture shows me that I have 60 volts from the battery. Could I solve for my current? Yeah, what's 60 divided by 15? Oh yeah, whoops. Oof, that's bad math on my part, sorry. 4 amps. So the total current going to be flowing throughout is going to be 4 amps. 4 amps. What do you think? The equation?
Well, like, just like the difference between them.
No. Like, you'll always be given those equations. It's just, can you look at it and use it? Okay. All right, so I know you guys are kind of like, that's a little different. I don't know. I'm not quite sure if I like this yet or not. Okay? All right, look at this picture down here. Find me 2 resistors that I know for sure are in series or for sure are in parallel. What about these 2? Those 2 are what? Series. And these 2 are what? Parallel. All right, you guys want to do 2 steps at once? All right, so draw your next circuit. So I have a battery. I still have resistor 1, which is 4 ohms. This is still 10 ohms. Okay. But in the middle, R2 and R3, those were in series. So how do I figure out the equivalent resistance for those 2? Just add them. So what's 8 plus 4? 12. All right, so this one's now 12 ohms. And then your last 2 on the right that you circled for parallel, I have R5 and RA, which is 4 ohms and 4 ohms. Okay. So help me out. 1 over 4 plus 1 over 4 is 2 over 4. And then what do I have to do? Flip. So what's my equivalent resistance there? 2. All right. Looking at my picture, these 2 are definitely in what? Series. Okay, so let's go ahead. Let's do the next one. Do your next circuit. So I still have my 4 ohms, my 12 ohms. Since those are in series, what's my total resistance there? 10 and 2 makes 12. All right, now, once you get to this point, you might be like, I don't know. Follow the current. And I'm sorry, that's a little stockiness. That's just me being lazy. Follow your current. Follow the wires. Okay, I'm going this way. I go across this resistor, and then it splits. So what does that mean about these two? These two are in parallel, right? So then if I draw my next circuit, I know, so much work. I hear it. All right, so for parallel, I add 1 over 12 plus 1 over 12 is 2/12. And then I got to flip it. When I flip it, what do I get? 6. All right, so now it's a little bit easier to see that this one is in series now with the equivalent resistance of those two. So now, final step. Boom, boom. How many ohms total? 10. Boom. What do you think? Not too bad? But the thing is, you got to take it one step at a time, because when you first look at your initial picture, you got to find ones that are obviously in series or obviously in parallel. Remember, when it's in parallel, that current gets split. So even on this picture where they weren't parallel or lines drawn like this, it was a little bit different. The current still split, and once it split, I knew then that they were in parallel. So that's the hardest part. When you start going through and you're doing your equivalent resistance, it's about taking it one step at a time. Don't try to do too many things at once and skip things, okay? Because if I tried to do the total equivalence here, just looking at that picture, I probably would have messed up. Probably would have. There's no quick shortcut way to this. It helps as you draw each step to do the equivalent resistance, to circle the ones that you're solving for, put an S or put a P, so you remind yourself, I'm solving for it in terms of series, or I'm solving for it in terms of parallel, okay? All right, so reminder, if they are in series, you're just adding it straight up. So resistor 1 plus resistor 2 plus resistor 3. If they are in parallel, though, you're adding it as 1 over. So 1 over 2 plus 1 over 2 plus 1 over 2. And then once you add it, you got to flip it, okay? So this one does require that flip because it's 1 over the equivalent resistance. And what I'm really looking for is the total equivalent resistance, okay? All right, so let's try. I'm going to change these values since we did this guy a little bit earlier. I think that one 4. Make that one 10. And we'll make that one 2. Okay? All right, so tell me, what am I going to do? First step. Who am I going to resolve first?
R2 and R3.
2 and 3. Okay, they are in parallel. I have 4 and 8. So 1 over 4 plus 1 over 8. Flashback to, like, I don't know, when did you guys do fractions first in common denominators?
3rd grade.
I know that was a long time ago. A long, long time ago. Find a common denominator. Or if you really don't want to do that, there's this magical thing in your calculator where you can put parentheses 1 divided by 4, parentheses plus parentheses 1 divided by 8, parentheses equals blah, and then hit inverse -1. Do it for you. Or just find the common denominator. Either or, okay? So you don't have to do the calculator version because most of these will have a common denominator. So the common denominator here would be 8. So this is 2/8 plus 1/8 makes 3/8. Now you got to flip it. right? So my equivalent resistance there is going to be what? 2.67. Okay. So draw your next picture. So practice drawing your next picture. Okay. And then last one. Boom, boom, boom. Those are all in series. So the nice thing with the one once they're in series is it's so much faster because you just add it up. Boom, boom. So you get 10, 11, 12, 13, 14, 14.67 ohms. Your final drawing will always have your battery and one resistor. That's the end all goal, okay? So if at the end you're not finishing with just this, then you gotta be like, uh-oh, what did I mess up on?
Wait, do we need a picture? Like on a test, there has to be a picture.
Yeah. So on the test, you will actually show me this goes to this and then this to this, okay? I will tell you on the test, the bonus problem is gonna be like a big one. Okay.
I like problems.
All right, take a look here.
I have a lot of them.
Each resistor is 2 ohms. Each resistor is 2 ohms. If I want, I can do 2 at once. These 2 are in series, these 2 are in parallel, right? So my next picture, since that is in series, 2 plus 2 gives me 4. And then if these both are 2, 1 over 2 plus 1 over 2, 1. Flip it, 1. Nice. And then last one, these guys are in series. Equivalent resistance is 5 ohms. Boom. What do you think? Not too bad? It's kind of fun. It's like a jigsaw type problem. You guys will actually like it. I promise you, you will actually like it. Okay?